So, where we left off, we had the dude chasing us, shooting us, but the problem was that he wasn't aiming where we were moving, but rather where we were right before we moved. So, if we were to chase at him and just walk a little to the left, you can notice he's aiming at us when we stop moving, but once we move, he's still shooting at where we were before rather than where we predicted our move should be. So, we're going to do some predictions. And to do predictions, we actually need the speed of the object. And so for that, we're going to go into our physics controller and we're going to make a function. So we're going to make a public function, call it, let's see, float or double. Double get speed, right? And then inside here, we can just make it a double shooter AI. Whoops, not shooter AI. Sorry, wrong place. Physics controller, actually. And the purpose of this function is just to get the speed, and to do that, we just need the magnitude of the vector. So we can have a double answer, or double speed equals to so sweet. So now we got the thing that gives us our rate of change of velocity, which is or rate of change of distance, which is velocity, and now we have the speed. If you remember your what do we call physics, we had the whole d equals v equals d over t. So we're going to be using that in our shoot functions. So what we're going to do is we're going to add a little bit of visualization so we can see some things happening. And the one that we are actually going to add at the most would be over here. So we're going to add a visualizer here, and it's going to be your line, so we can see where it's aiming, or what it's aiming straight at. So we can do that. Alright, after adding the line, you can see that we're using double precision, so you have to be careful. Position is a capital vec3, which is basically double vec3, and the direction is a smaller vec3, which is a float. So you might want to have to cast it to a vector 3 to do this. Alright, with that, we get a line that shows us where it's aiming, and now what we can do is we can get that shoot working out. So what we need is point that shows us where we will be in the future. So we can use Unigine vector 3. We're going to use the big one, point, and we can just call it future point, right? And with this future point, what it's going to do is it's going to take our current position plus the speed that we're going, and it's going to give us a prediction of where we're supposed to be in the future. So we're going to do main character, world position plus main character get body linear velocity dot normalize. Alright, so the normalize gives us a unit vector, and the world position gives us the position vector. Now this is small v, so just like this, we're going to have to typecast it and make it the big V. Alright, with that, now we have a future point. We can visualize this. Alright, so now we have this point that will show us where the future is. We can also do a capsule, and the capsule controller is just so we can have a nice little visualization of the dude itself. So we can also add that. So with that, we have we have our future point, and we have our capsule. So let's try this again. Alright, we're in its position and it expects us to move around that much. Now as you can see, the point is a little bit down, so we can fix that later, but now we have a position where it expects us to be. If we just move a little bit slower, it expects us to be there, and we would be there if he shot at us. So let's fix that a little bit. So now we have this looks like the point's not working, but now we have this area where it expects us to be, and we're gonna code the ability for it to change it. Alright, so now with that, what we're gonna do is we're gonna take the distance, the speed, and the other distance. So the distance between our future prediction and our current prediction. We're also going to take the distance between the enemy and the character, and we're also going to take the speed that we already have. So for speed, we're just going to include physics controller, right? And might as well add it into the CPP so we can. No, actually no. We don't really need to add it to the CPP. So in our shoot, now that we have the visualizers, let's do some little math over here. Now the first thing we're gonna do is we are going to get our doubles. We're going to get first the future distance, and that equals to alright, so now we got the distance of between us and the future distance, then the regular distance. So now we have the distance between the AI and us, and we have the distance between the main character and its future position, and now we just need the speed. Alright, so that connects that, that connects that, and that connects that. So what we're going to do is we're going to add some logic to it. When we looked at moving, we also noticed that when we were moving, there was a certain little percentage that we didn't reach there even when the bullet got to where we were in terms of distance, right? So we're also going to have to account in the speed and the distance factor. So there's going to be a little ratio, and if we move slower it's going to be different, and if we move faster it's going to be different. So what are we going to do? Right here, if statements are always the best. So we're going to do a simple speed check and see if it's less than or equal to 1, and if it's between and if it's greater than 0, right? Right, so if it's between 0 and 1, there's a ratio, right? And with that ratio, what we're going to do is we're going to use these two functions. So let's just copy. Well, actually, no, we don't really need to copy these functions. We just need to copy this one, where we're looking at and when we're shooting. So that's the more important thing, because this one sets it in that position, this one sets the damage, this one gets some afterwards, and then we're going to be using these to set its controls. So first thing we're going to do is we're going to do the bullet and world look at. So we're going to be looking at, and we're going to be looking at a percentage between where we moved / where we are, and that percentage is taken in with your whole equations. And what I found was we can take the lerp between our current position and our future position and get a ratio out of it. So main character world position. Alright, and then future position, and then we can lerp it between the distance, the speed and the distance, and get the time out of it. So we can do speed divided by future distance. So that's going to give us the time that we need, right? Because speed is velocity and distance is distance. Using your equation, you're going to get the time, and I wonder if I wrote that right. I'm not too sure. But anyways, we're going to do that, and then after that, we're going to tell it to... Okay, we can move this up here. Oops. We can move that up here. We don't really need to initialize it every time inside the if statement. So the only two functions that we really just have to moderate is these two. So we can just do this. Let me just put that there so it looks cleaner. Okay, so now we can add that linear impulse. Alright, so instead of adding the linear impulse with times 50, an arbitrary number, what we can add is actually the distance. Right, the further you are, the more it shoots, and the closer you are, the less force it takes. Now, this isn't real life, so there's no such thing as consistent simulation. I mean, if you want, go ahead, but this gives you more of a speed chance to dodge, right? Because if it's closer, you can see this, you can see the bullet coming at you, and you have time to react. So as a game, you need to make sure that your game's very reactive, or it's fun. So this is a good reason to give it a factor of speed. Now, let's say we are still speeding, but here's the thing: our ratio of speed went beyond 1. So what we're gonna do for this is, let's just write it, went beyond 1. So we're just gonna copy and paste this whole line again. Actually, do we need to? Let's just copy and paste these two, and we're gonna do a little bit of change. So first things first, we don't really need to look at the lerping, because now the lerping was a percentage between that maximum side. Now the speed's beyond 1, so it's actually gonna have to go a little bit more. So what we're gonna do is we're gonna just look at the future position. Alright, so now we're looking at that future position, and then the impulse can have that distance times that ratio. So now it'll get there in that time. So then we could do this, and we could just say speed times future distance. Alright, so that gives us that ratio, and it's going to speed up by that ratio of how fast it will get to get there. Now, if all else fails, he's not moving at all, right? Then we could just tell him to shoot straight ahead and get the guy. So, and at the same time, distance. Alright, so that gives me enough leeway to do some more procedural physics. Let's see if that works. So the main reason we do this is so we can check if he actually aims properly. Okay, he's aiming perfectly, shooting us exactly where we landed. And if I went a little bit faster, as you can see, I am still getting hit because, well, I'm still in his range, right? So, perfect. Let's try to dodge it. There you go. Okay, he's still aiming at me properly. Okay, so that's beautiful. Alright, so now that I'm running too fast, he can't really, but as you can see, if you're aiming with a gun, you're gonna have to be this slow. But if you're running away, he actually doesn't have the ability to catch you. So let's just pick up our gun. Oh boy, he went down. There you go, and now we died. Alright, so we have it perfectly connecting it together. And the reason why I went into assertion is null is because we asked the bullet to kill the object, so it killed the main character, and it was calling it. So you need to do extra logic for that. So in reality, you just don't need to, do this part. Or actually, sorry, my bad. Not this, but the health bar. When the health bar goes 0, kill the guy. We don't need to kill him. We could just say he's dead, technically, or give the status that he died, so he can respawn or something. But anyways, that is how you get your physics to, or your physics bullet to hit at a proper ratio, connect 100%, and have a 100% kill death ratio. Now, how do you change this in terms of difficulty? So since this is 100%, what you can do is you can give it a 90% or an 80%. So you can just change the ratio over here, right? And what you can do is like speed times chance, right? So if the chance is 90%, it'll be 90% close to the speed ratio, so he will just hit. So if he just decides to change a little bit, he's gonna get hit. And if it's like 70% or something, so you can play around with this, but this is your physics. Anyways, I've talked enough. I will see you guys next week. Until then, goodbye.